We are Infrared Cameras Inc. from Beaumont, Texas. We are introducing our Halo system, which is the drone. And the camera package you see on it now includes the Mirage HC, which stands for hydrocarbon. It is an optical gas imaging camera designed to see hydrocarbon. So I'm holding a lighter. I'm going to let the butane fumes without lighting it. And you can actually see the fumes in the scene. We also have a visible camera on board with a 30x optical zoom. We have full control through the DJI controller that allows us to adjust palettes, the spot temperature, cold spot, center point, hot spot. We can adjust the level and span, manually controlling the max and min temperature level that the color palette is applied to. And that is important out in the field when you're trying to get your dynamic range right so you can see the gas. If you have something real hot in the scene, it can shallow everything and make everything look kind of flat. Digital zoom, of course. And we also have full control of the gimbal right from the controller. And when we capture an image, we capture an image from both the mid-wave and the visible camera simultaneously, and we geotag that data and store it. And then we have post-processing software that allows you to take that image set, analyze it, generate a report on it within a couple of minutes.
Now, does this software, does it actually do mapping, or you would use a different mapping software to map?
Our software will have, we're working on an API that when you load the image set, you'll be able to send it to a 2D mapping protocol that'll build the map and leave the radiometry in place, which really nobody has that in place yet.
Excellent.
All right. The Matrice 200 series is the latest industrial platform from DJI. There's 3 different models, the 200, the 210, and the 210 RTK. The 200 supports a single gimbal and has the FPV camera. The 210 moves you into the ability to have 2 different cameras in different locations. So I can have the FPV and a single camera on the bottom, FPV and a camera on top. I can have 2 cameras on the bottom, so any combination of 2 cameras that can go on here. It supports cameras such as the XT, the Z30, the X4S, and the X5S. The step up from that is this one here, which is the 210 RTK, which is the same as the 210, but adds the DRTK system for 1 centimeter position hold accuracy. So that's the top of the line there. Over here, we have the 210 outfitted with the top mount and a bottom mount camera. So you can see the different configurations that are available. The Inspire 1, we always call the i1, the Inspire 1 is still available, and it can support the variety of cameras from the X3, the X5, X5R, the XT. It can actually handle the thermal camera. The Z3, which is a 3 times optical zoom. Moving up from the i1 is the Inspire 2, which can do the X4S and X5S cameras today, but not the thermal camera. So unfortunately, the thermal is not available on the Inspire 2 at this point. So if you want thermal, you're going to be Inspire 1 or the new M200 series. And then we have the Big Bird, the M600, the big hexacopter that has 15, 18-pound payload capacity. You can easily do things like LiDAR systems, heavier camera platforms, bigger sensors. So if you need that heavy lift, that's where the Matrice 600 comes in.
Today what we're going to be talking about is our Nitros, which is a optical gas imaging camera system. The purpose of the camera is to be able to detect approximately 22 different hydrocarbon gases. We do that with, we start off with the base mid-wavelength thermal imaging camera, which is a cool camera, meaning that it uses what's called a closed cycle Stirling cooler. And the reason for that is because the camera uses what's called an indium antimonide or InSpeed detector. Then what we do in order to be able to detect and visualize the gas is we use what's called a narrow bandpass filter that is specifically designed to look at the absorption of the wavelengths of these hydrocarbon gases, which falls between about 3.2 and about 3.4 microns. So this is our current camera, which again is referred to as the Nitros. We've been manufacturing this camera for several years now. And on the camera, this is what we refer to as an open frame camera core because the electronics are actually exposed. We can wrap a housing around this, but most of our customers end up integrating it into like a gimbal or into their own enclosure. So we normally, and most of the time, provide it in this configuration. This part of the camera on the back is called, again, closed cycle Stirling cooler. There's then what's called the Dewar section of the camera, and inside the Dewar is where the actual focal plane array is, and also where we integrate the narrow bandpass cold filter. You then have an optic on the front of the camera. This uses a germanium lens, typically for optical gas imaging. If you're only flying at, say, 120 meters or so, you would typically use like a 25 millimeter type lens. Once you get beyond about 25 meters, then you just set it to infinity, and then you would be able to image continuously with no adjustments to the image. There's a lot of different interfaces that we offer with the camera. One would be just standard composite video output, which would be in the form of NTSC or PAL. We also have what's called gigabit Ethernet. We also have H.264, and we have what's called digital camera link. You can also use serial control for communications, RS-232 or RS-422. There's also input and output triggers on the cameras as well. So this camera currently with the lens weighs approximately about 3.5 pounds. And we again have had this camera for the last several years, and we're going to be moving to a smaller camera, and it's going to reduce the size, weight, and power of the camera to about 1.5 pounds. Yeah, so what you're viewing right now on the monitor is an actual survey that we did where we located an underground natural gas leak. The area which looks kind of like a smoke or it's a dark plume, that's the actual gas leak itself. Normally, again, with your eye, you wouldn't be able to see that. There is some indication there is a problem because the gas has been there for a long time. It's killing all the vegetation. That's the white area that you see in the background across here. And of course, you have the plume area all in this area right there. So it enables you to be able to visualize where that is, so that then for the company that you're doing this for, you can give them a precise location of where the leak is, and then they can generate a work order to repair that.
Hi, so I'm going to tell you a little bit about the Albris by Senseline. So this is it's an inspection and close mapping drone, and Ray's been just explaining to me here the type of work that it might be used for. So you have 3 sensors in the head. You have a 38 megapixel RGB still, you have a HD video camera, and you have a thermal infrared camera. You also have a lot of sensors around the drone for advanced awareness of where the drone is. One of the applications of this is 3D modeling of sites. Like they could be rail cars, they could be a building or a cell tower. And in the software, what you do is you load up the map of that site, and you use one of the mission blocks to automate the capturing of images around that site. Then from there you'll pipe those images into like Pix4D software or Agisoft to create a 3D model and a point cloud of that site. So what this does is makes that very, very simple, and during the flight you can flick on a thermal overlay as well. So You can do that on the same flight or on separate flights. For the Albris, we sell that all over the States. We have distributors in most states. And that's going to run around 20K, which includes all the sensors. It's non-modular, it's a fully integrated system. And that includes the eMotion flight planning software, which makes that kind of modeling fully automatic.
Ed McCaffrey, I'm the regional manager for UAVs with TopCon. This is the TopCon Intel Falcon 8 Plus. This particular camera is designed so that it will live stream video, shoot RGB photos with a 30 power optical zoom lens, and thermal imaging all at the same time. When I trigger the unit, it's going to capture and georeference both at the same time, so I do not have to switch cameras, nor do I have to go back and forth between the sensors. There are a wide range of sensors that this will do. It's designed for inspection and mapping. Very similar to what you're doing. It will be similar to the way Airbus and others are using the Falcon 8 to fly, measure, and inspect aircraft. So you don't have to put people in dangerous situations. In the case of an airplane, you obviously can't climb all over it. In the case of cars, you may not want to climb. This is going to map, so you can map the entire thing and then go back in for close-ups, and it'll georeference. The software will push it all out, so you get 3D orthomosaics, you will get LiDAR point clouds that you can manipulate, as well as surface models, so I can measure absolutely anything, view and inspect absolutely anything. This platform has been out since 2009, so it's a very well-known system. Again, oil and gas industry in the North Sea, because of needing lots of maneuverability and very high winds changing direction quickly, this is about the only one that we do. Intel, 6 months or so ago, purchased the German company Sending Technologies and became our partner. Working together with them, we also have a fixed wing solution for large areas that they also went out and bought our partner in that case. And it's been a really good working relationship between ourselves, and we understand.
Okay.
So this is actually a college campus. That's a 3.5 mile by 3.5 mile area. You obviously would be doing much smaller areas, but to give you an idea of the resolution from 200 feet.
Stuff like that. That's my military. That's what I do.
I'm getting extremely good accuracy and detail. Now, what you're actually seeing here is not photographs. This is the 3D model that is built. So, again, if you're looking at things like detail on the roof, and again, this is from 200 feet in the air, you would be much lower than this more than likely, so your detail would be better. We would typically be able to see, for example, bridge and building inspections. I can see a millimeter-sized crack and detect it. So the other thing that this will allow you to do by using either the images or the model is you have dated, verified data, and it will allow you the ability it will allow you to compare and contrast between dates. You can take a look at it. Now you would have the data, you would have the pictures, you would have all of that stuff. It normally is going to automatically send you not only the images that are all georeferenced, but it will give you a 3D orthomosaic, it'll give you an LAS or an LAZ point cloud file, and it'll give you a digital surface and elevation model. If you have things that are scanned, you scan part of it and fly part of it, you can merge those together.
When you say scan,
So if you had, say, a LiDAR
oh, I got you.
scanner or a mobile mapper, you could map whatever it is, and those typically create an LAS point cloud file. You can take that data and the LAS file that this will do, merge them together, and it will integrate all of it into one.